Hi, I'm Gouri Nanda. My registration number is 23MIA1006. I have chosen the topic ElGamal cryptography for my network security and cryptography fundamentals DA. So let's delve into the topic. ElGamal cryptography. It is an asymmetric key encryption based on public key cryptography algorithm, and it is built on the difficulty solving the discrete logarithms problem, which is DLP. ElGamal is used for encryption, key exchange, and digital signatures. Let's see the introduction of ElGamal. It is it was introduced by Tahir ElGamal in 1985 as a robust method for public key cryptography. Its foundation lies in the principle of the Diffie-Hellman key exchange. So let's see what is Diffie-Hellman key exchange. It's a method which lets two people share a secret key over a public channel without anyone else being able to figure it out, which makes it a vital component in secure communications. Public key encryption key. At the public key encryption scheme, ElGamal utilizes a pair of keys, a public key for encryption and a private key for decryption, ensuring secure communication between parties. Applications in secure communication. ElGamal is utilized in various applications such as PGP, pretty good privacy, blockchain technology, and secure communications, showcases its versatility and reliability in safeguarding data. Secure encryption through randomness. The core principle of ElGamal is to encrypt the data using randomness and modular arithmetic, which enhance security by ensuring that the same plain text can produce different ciphertext. Matrix encryption with key pairs. ElGamal utilizes asymmetric encryption incorporating a pair of keys, a public key for encryption and a private key for decryption. This method ensures that even if the public key is widely shared, only the holder of the private key can decrypt the information, enhancing security. A robust security through complexity. ElGamal is rooted in the discrete logarithm problem, which is computationally challenging to reverse. This difficulty makes it more secure against certain attacks compared to other algorithms. Additionally, it generates different ciphertext for identical plain text, offering some enhanced semantic security over RSA's deterministic encryption. So, what is RSA? It is Rivest Shamir Altimon, which is widely used public key crypto system. Now, let's see the key concepts. Modular arithmetic. It is an essential for the operation in algorithms as it ensures the result remain with the certain range defined by the prime number P. What is prime number P? It's a fundamental part of algorithm, providing the security foundation for the encryption process and ensuring the mathematical operations are valid. Generator or base EI. It is used to create public and private keys, serving as starting point for the exponentiation calculations in the encryption process. Private key D. It is kept secret by the user and it's crucial for decrypting the data encrypted with the public key. It plays a very vital role in maintaining security. Public even E2P allows anyone to encrypt the messages for the key owner, facilitating secure communication without exposing the private key. A random number R is generated for each encryption, adding an element of unpredictability and ensuring that the same plaintext occurs in different ciphertexts each time. Now let's see the key generations in ElGamal. Prime number P used in ElGamal is P11, serving as a very crucial component in the encryption process. Private key D, which is denoted as D equal to 3, which is kept secret and used to decrypt messages. Generator or base E1. The generator or base used in ElGamal is E1 equal to 2, which helps in generating public keys and encrypting data. Public key E1 E2 P, where E2 is calculated as V1 raised to D mod P, resulting in E2 equal to 8. The full public key is 2811. Now, let's see step 2, which is encryption. Understanding the encryption process in ElGamal cryptography using specific calculations. Given values, the plaintext dating is 7 and the random number R is 4, which are essential for the encryption calculations. Step 1 is to calculate C1. C1 is calculated using the formula A1 raised to R mod P, resulting in C1 equal to 5. This step establishes the first part of the ciphertext. Step 2 is to calculate C2. It's computed as Pt into E2 raised to R mod P, which results in C2 equal to 6. This concludes the encryption process. Final ciphertext will be represented as C1 C2 equal to 5 6, encapsulating the encrypted message. Let's see step 3, which is decryption. To decrypt the ciphertext, first calculate C1 raised to D mod P, here which is 5 raised to 3 mod 11, which is equal to 4. Next, find the modular inverse of this circle, which is the value of x. Inverse of 4 modular 11 is. Finally, recover the plaintext by C2 into x mod P. Here it is 6 into 3 mod 11 equal to 7. The entire decryption process confirms that the original plaintext is 7 is accurately retrieved. Now, let's see the summary table. Here, prime P was 11, which is the prime number used in the encryption process, crucial for generating the keys, and the public key 2811 that can be shared with anyone for the encryption process consisting of multiple components. And the plaintext 7, the original message before encryption, which will be transferred into the ciphertext. And the decrypted text 7, the result of the decryption process, which will confirming the successful retrieval of the original message. Private key D is 3, which is used for decryption, kept secret by the user. Next is random R4. Random value used during the encryption process to ensure that unique ciphertext for very identical plaintext. Ciphertext 5,6, the encrypted output of the plaintext, which is sent over secure channel. Let's see what are the applications of ElGamal cryptography. ElGamal cryptography is widely used in several critical applications, including TGP, for secure email communications, secure messaging protocols that ensure confidentiality, blockchain technology for secure key exchange, and digital signatures that verify authenticity. The algorithm's reliance on semantic security and randomness makes it resilient against chosen plaintext attacks, enhancing the overall security of these applications. Now let's see the limitations of ElGamal. ElGamal's limitations include generating ciphertext that is twice the size of the original plaintext, making it very less efficient for storage and transmission. Additionally, this ElGamal encryption are very slower than the RSA. RSA is a reverse chamber algorithm which we discussed earlier, widely used, publicly resistant, particularly when dealing with large data due to the computational complexity of their operations. Comparison with RSA, which is a deterministic algorithm, meaning it produces the same ciphertext with the same plain text input. This can lead vulnerabilities in certain contexts. However, RSA, which has a typical requires shorter key length, which is a similar level of security compared to ElGamal, offers semantic security feature not present in RSA, protecting against chosen plaintext attack. So this is all about my presentation. Thank you.